The following data represent the number of available cars in a household based on a random sample of 50 households. Construct a frequency and relative frequency distribution. So that's what we did yesterday. We talked about how to make those things. So let's refresh. What would I put for my columns? So we'll do number of cars, the frequency, and the relative frequency. You could do this on a Chromebook or by hand. It's not a lot of work either way. So my options, it looks like we have 0 up through 5 for the number of cars. Okay, how do we get the frequency? So 0 shows up 1, 2, 3, 4 times. Is this on the notes that I printed you? Yeah. Okay. I find it useful to mark off numbers as I use them. That way I make sure at the end, if I don't have one that's marked off, I know I missed it. I can go back and adjust. 1, I've got 1, 2, 3. Did you guys get 13 ones? Yes. 2. 22 twos. Seven threes. 3 fours and 1 5. How could I quickly check and make sure that I got them all? Add them up. I already told you that there were 50. So does this add up to 50? All right, so we've got them all. Then how do I get my relative frequencies? All right, so 4 over 50, 0.08, 13 over 50, 0.26, 22 over 50 is 0.44, 7 over 50, 0.14, 3 over 50, 0.06, and 1 over 50, 0.02. Okay, so there's our frequency and relative frequency distribution. That's what we were doing yesterday. We could make a bar graph for this. Another option that is extremely similar to a bar graph is a histogram. So in a histogram, you draw rectangles for each class of data, just like in a bar graph. The height is the frequency, just like in a bar graph. The width of each rectangle is the same. So that means if I'm going up to 5 cars, even if maybe nobody had 3, I would have to include it on my graph so that we're just going up by 1 each time. I can't only put the numbers that show up. We have to be sequential in it. And our rectangles have to touch when we draw it. That is the one big difference from the bar graph. We do have to make sure we have numerical values, so increasing by consistent amounts, and those rectangles touch when we graph them. Is draw a histogram for the data that we had. So we did the number of cars, we have the frequencies, we have the relative frequencies. So I want to, I think my directions on this example said draw both of them, but let's just draw one, either the frequency or the relative frequency histogram. What's going to be the only difference when I make those histograms, just like when I make those bar graphs? The difference between plotting the frequencies and the relative frequencies. The label on the y-axis. Either it's going to be something like 1, 2, 3, 4, or it's going to be 0.1, 0.2, 0.3, 0.4. So that is the only difference there. Which one do you want me to draw? Frequency. Okay. So we have our x and y axis here. What we're going to do, I am going to go ahead and put a tick mark for the 0 cars, and I'll show you why in a second. So this is going to be my 0, 1, 2. And if I had someone that had like 7 cars, I would have to even include the 6, even though there weren't any families of 6, to get to my 7. You can't just jump around. Okay, so there's my number of cars. And over here we're going to put the frequency. So our frequencies, the highest was what? 22. Let's just count by 2s. In order to draw these rectangles touching, what we actually do to show the 0 one is we draw a rectangle that's centered around the 0. So how many families had 0 cars? 4. So we'll draw it up to 4. I'm going to start it here and end it here. So it's just centered over that 0. So for my 1, we had 13. These rectangles are touching. This one picks up there. And here. Hopefully you're a little better at drawing straight lines than I am. Okay, then the 2, we had 22. Three, we had 7. 4, we had 3. And 5, we only had 1. So does everyone see the difference between just a regular bar graph and a histogram? We kind of smush it all together. We center our rectangles over the number. The only thing that would change if I wanted relative frequencies, these labels over here would change, but everything else would look the same. So your relative frequencies would be like 0.2, 0.4, 0.6, 0.8, and so forth. All right. Any questions about that? Sometimes our data is so widespread that we may not want to just count the number of responses. For instance, if I was looking at grade in the class, okay, but I didn't round it to the nearest percent, you could have a 97.1, you could have a 97.12, a 97.125. So there's a lot of answers there. Would I want to take every single one of your grades and draw a bar for each of those? No, because it wouldn't really show me much. You might all have something different. What we do in that case is we make classes. So I might say, if your grade falls between a 90 and a 94, you know, kind of like our ABCD scale. If you're between here, you get an A. If you're in here, you get an A minus. So when I divide it into groups like that, those are classes. All you really need to write down will probably be that what I underlined there. We use that if we have a large set with different answers. Also like continuous data, so that grades. When your answers can be decimals, that would be a good situation to use classes. So here is an example. The following data represent the time between eruptions in seconds for a random sample of 45 eruptions at Old Faithful. Construct a frequency and relative frequency distribution. Okay, this is discrete data because I rounded it to the nearest second, but do you see a lot of repeated numbers here? No, so it's probably not going to show me a lot if I just graph each one of these numbers separately. This would be a situation where we might use classes to show it. Let's see if we can find our lowest and our highest numbers for that. So my lowest, here's a
690.
672. 72.
72.
Yeah, it's kind of annoying when you have a huge set of data, isn't it? Okay, what is the largest one we can find?
38.
738, I think. Okay. So we'll talk about different ways to make our classes, you know, how big we might want them to be and that kind of thing. For my table, my first column is going to be time. And it starts at 672. We have to go all the way up to 738. So how about we just start at 670 and we go up by 10 each time, okay? So the first class will be, I don't want to say between 670 and 680 because I want the next one to start at 680. So where should I stop this first one? Okay. What if I had decimals? If I had all like one decimal place on each of these, what would you have to stop at? 679.9. Okay, if I had two decimal places, you would stop at 679.99. All right, so then this will be 680 to 689, 690 to 699, 700 to 709, 710. So how many classes do I have? 7. Okay. So we need to get the frequency and the relative frequency. Let's divvy this up. You guys had what? 7?
8. 11.
7. All right. This is set up to 45. I think we're missing one. Doesn't it add up to 44? I think this least that's what I got when I counted them. Okay, how do we get our relative frequencies? All right, I told you that there were 45. If I didn't tell you, you would just count them. So then we'll just go through and divide by 45. So 2 over 45.
How many decimal places do you have?
Usually 3 to 4. 0 divided by 45. If we've done it correctly, what should these relative frequencies add up to?
1.
Okay, let's check that real quick. This one. So mine added up to 1 exactly. Is it possible that it won't add up to exactly 1? Yes, due to rounding error, but it should be very, very close. All right, so we made our histograms. We're all good on how to do that? Okay, for making a histogram using technology, on Google Sheets, it is not real friendly because it wants to do bar graphs all the time. So we are going to now kind of switch gears and start using our graphing calculator to do a lot of this stuff. So everybody get a calculator. If you want to practice following along, like using the book, I believe it was on page 86 that there were step-by-step directions. So later on, if you're trying to do it on your homework and you get stuck, you've got all these blue boxes tell you how to do things on technology. And the very first one is the TI 8384. So it gives you step-by-step exactly what we need to do to work on this. Okay, so first thing we always have to do is enter our data. So we are going to go to our list. Okay. So if you hit the Stat button, and then the first one, Edit, we have list data. Now let me tell you a few things about your lists here. Everything is easier if your lists are L1, L2, L3, L4, L5, okay? It is possible to delete a list off your calculator. Like you could accidentally delete L1. Then you have to make a lot of other changes later on. So we don't want to do that. If I want to clear out all the stuff that's here, you can use your up button to go on top of the title. Don't hit delete, hit clear and enter, and it'll wipe out everything in that list. So I need to delete out all my lists. So I'm going to go clear, enter. If you hit delete, your list will disappear, and then you want to ask me to help you get it back. Okay. All right. So our L1, we aren't going to put we're not going to put our classes in here. We are going to enter the actual data from that table. Okay, so you're going to type in those 45 numbers. Go. You can just type in one and hit enter. It'll go to the next.
Does it matter which way we go?
No, order that you put them in will not make a difference.
If you type in one number wrong, will everything be wrong? Yep.
Yeah, definitely.
Okay, now we are going to try to get a graph. So you need to push second and this y equals. This takes you into your stat plot. So you can remember all the times in college algebra when you raise your hand, you're like, my calculator won't graph anything. That's because somebody left the stat plot on. So you be nice to my other classes and turn the stat plot off when we're done, okay? So it tells me number 1, plot 1 off. I need to turn that on. So you can use your arrows to go to that. You can hit, and mine froze.
Wait, let me press second and then
Y equals. The downside of this graphing calculator on my computer is it freezes all the time. Here we go. Okay, so second, Y equals. Okay, we want to go to number 1. If you hit enter, you'll see your cursor is flashing on the on. Just hit enter to select that. So now you have turned that on. Now we can go to type. These are all the different graphs your calculator can do. So it can do like a dot plot, a line graph. We want the third one over. We want a histogram. Okay. Then it says like X list is L1. As long as you haven't deleted out your L1, all of that stuff will be correct. So that's why I like to keep that there so we don't have to change anything. Now, if you just hit graph, you're probably not going to see a whole lot because our window is funky. So we need to adjust our window. I also had something entered in my Y equals. So if you do have that, you might need to delete it out.
Mine says invalid.
To turn your plot on?
No, that's graph.
Okay. Don't worry about that hit window. Okay, so we need to adjust this stuff to see our data. If you think about our X values, our smallest was 670 and our biggest was 738, right? If we're going from -10 to 10, we're not seeing any of our data. So my X min, let's just do 670. Your X max, you need to go at least to 738. You can go bigger. I'll just go 750. That way I can see everything. Your scale, what it's counting by, you can leave it at 1. If you want to speed up your calculator, like if there's a big range of numbers, you can bump that up. So maybe I'll go 10. It doesn't make a huge difference. Just kind of helps your calculator a little bit. My Y's, I have between -10 and 10. Do we have any negatives? No, so let's just set it at 0. Our highest, let's set it at 15. Okay. So everybody has your X-min at 670, your max at 750. Scale is 10. I also picked 10 because that was how big of our classes we did when we set it up. And I adjusted my Y so I could see everything. All right. Everybody good there? Now hit graph. And it just built it for us. Because my X scale was 10, the same as my classes, this graph matches exactly what it would be if we did our histogram by hand. If you set your X scale to 5, then you'd have double the rectangles because they would have only been 5 apart. Your classes would have been 5 apart. All right. So we can use this to draw histograms. We don't have to do them all by hand. Questions on that?
So will we do those on the Chromebook and then like for homework and stuff?
Next one, stem and leaf. So you have done stem and leaf plots before. The stem, use everything to the left of the rightmost digit to form the stem. So if it's a 2-digit number, you'll have 1 digit for your stem. If it's a 3-digit number, you would have 2 in your stem and only 1 in your leaf. Okay, so only the rightmost digit goes in the leaf, everything else goes in the stem. Let's say our number was 25.4. My stem would be that 25, and then this would act as your decimal, and then we'd have the 4 over here. So only 1 digit goes on the leaf side. You
I
have
just don't understand the definition.
okay. The rightmost digit is the number on the right. So I'm saying
Which one's the stem? Like
So, okay, your stem is everything to the right of that last digit. So here the stem would be 2. Here the stem would be 25. 25. Your leaf is just the rightmost number. So the 5, the 6, the 4. So when we draw, the stem will go in the first cone, the leaf will go in the second cone. Maybe when I show you, we'll look at an example and see if that helps. Okay? If it doesn't, then we'll come back to this. So here is a set of data, and I've listed every state and then the unemployment rate. So if you look at your rates, it's like 4.7, 6.8, 4.8, so forth. I'm not making you make the stem and leaf for this. Typically, I'm going to give you smaller sets of data when I'm asking you to do things by hand, but I've already made it for you. So your stem is going to be like the whole number, okay, the 4, 6, 8, but you'll notice we have a lot of these, 4.7, 4.8, 4.0, 4.3. Sometimes if you have a lot of points, you can make what's called a split stem. So I didn't specify. You know, you could have made this where your stem was just the 3 and your leaf, you list every digit that showed up. When I split it, my first 3 was everything between 3.0 and 3.4. My second 3 was 3.5 to 3.9, just because I had so many points in each group. When you list your leaves, you do want to put them in order, small to large. You don't have to put a comma beside them or between them or anything, you just list them, okay? So like my 3s, everything between 3.0 and 3.4. You had the 3, and then I had 2, 2, 2, and a 3. That means my points were 3.2, 3.2, 3.2, and 3.3. Yes?
Why is there 2 3s?
So that's when I did a split stem, just because there were so many points in each class. Like, if I had only did once, you'd have 2, 3, 4, 5, 6, 7, 8. And that would have been fine, because I didn't say you couldn't. But if you look at like your 5s, for instance, there are a ton of the 5s, so that just kind of broke them up in smaller
So you
groups.
were to find out 4 before
But it doesn't make a difference if it's all together.
No,
makes
just
sense.
different ways you might see it represented. I just wanted to make sure you could read it either way. Yeah.
How do we know if they're supposed to be this?
You would have the original data first. So I'm not just going to give you this, like if you just saw this, you wouldn't know if it was 28 or 2.8, but you'll always have the original data to look at too. Any other questions about this? These are all good questions. Okay. So we can do this on Google Sheets if you wanted to make one. You would just do like 2 columns. In one column you put all of your stems, and then the column on the right you just type your leaves if you wanted to type it, or you can do it by hand. When would this be better than a histogram? So I could make a histogram for this data.
Then they're also close together.
They're all so close together. You know, if you were going to do a histogram, you would definitely need to break it up into classes of like 0.5 in this case. What else? Yeah.
You're dealing with relatively small numbers.
Okay, we're dealing with relatively small numbers so that there's not a lot of space between them. When you look at the histogram, can you tell me what the original values were? No, I just see how many numbers showed up in each group. If you look at this, can you tell me what the original values were? Yes, so that is really the main advantage of the stem and leaf. You don't lose your original data. On the flip side, if you have a ton of data, stem and leaf can kind of become cumbersome, whereas a histogram is much more concise. You know, if I had 500 points, I don't want to make a stem and leaf for 500 different points. A histogram would definitely be easier in that scenario. Okay. Let's see. We're almost out of time, but let's talk about just a couple more things here.
We have to label Where it says this thing represents
No. If you just have those two sims, then I would assume that one represent each thing. Okay. One final type that we might see is a dot plot. And it's kind of like a bar graph. So if I were going back to the number of cars example, basically as you're going through your data, each time a number shows up, you put a dot there. So if, let's say my data was 0, 1, 3, 0, 2, 1, 0, 3. Okay, so I have 3 zeros, so you just stack 3 dots on each other. We had 2 1s, I only had 1 2, and I had 2 3s. So it's just putting a dot, and you just stack the dots on one another to represent all of your points.
Do you have a dot, like, do you have a scale? So like 1 dot could equal 3?
You could if you had very large sets of data. So for a small set, you wouldn't need to do that. But you know, if you were talking about hundreds of values, then you could do that. A dot representing so many.
How would we do that? Or we just write?
You would have to go out to the side, yep, and make a little legend. All right. Let's do one dot plot together, and then we're going to stop for today. So going back to that very first example we had, I gave you the number of cars in a household, right? And we drew a histogram for it. Let's do a dot plot for it instead. So I think on your example slides, I gave you that set of data again, so you don't have to flip back and forth. So we have number of cars, and we have the frequency. And our options were the 0, 1, 2, 3, 4, and 5. Okay, we could go back through and count them all, but we've also already done that. How many times did 0 show up?
4.
4. So you just do 4 zeros, 4 dots there. You do want to try to space them out the same every time. So 1, we had 13. 2, we had 22. 22 dots. 3, you had 7. 4, we had 3. And 5, we had 1. Is this a preferred method? Do you like drawing 22 dots? Probably not. It's easier to just draw a box going into 22. But it is another type of graph that you could see at some point, so I want to make sure you've seen it. Okay, so where we're at, I just have one thing left to cover out of this section. It'll take me just a couple minutes at the beginning of class tomorrow. So what I'm going to do, this is today's assignment. You have the section 2.1 from yesterday. So you have that if it's not finished, and this one. Tomorrow I will finish, so 5 minutes, and then you're going to have class time to work. So you don't necessarily have to do this as homework, you will have class time tomorrow.